Yeah, hi guys. Welcome to the session 3 that we are currently holding today. This is the follow-up session from your previous one where we had learnt some properties related to your parallel lines. There we had understood your alternate interior angles, corresponding angles, co-interior angles and why they were equal. So we had understood each and everything till there, and we had our exercise, I guess, 6.2 left, I guess, or 6.3. I guess 6.2 it was left. So we are going to pick up from there. I will be having one revision slide right here. I will be having making you revise each and everything. I hope you guys are already studying and you know what we are going to do. So let's start with the video and follow up with this one. So remember, this is your session 3 in which I will be trying to wrap it up, everything that this chapter has to offer. So we'll be covering up each and everything most probably today. If we are left with any exercise, I might be leaving some exercise. That means your exercise 6.3 that will be covered on Monday with a doubt session. So don't worry, I will be covering up your NCERT too, along with some important questions from various of books that you don't have to shuffle through. You can just even log on to our website and you can have as many test series there. You can have various practice questions to practice too as well. So don't worry, you don't have to shuffle from every book. You can just get yourself registered and have each and every question which is important that has been asked previously also. So all of those questions will be available there. You just have to just log on to that, download our application, and you can just begin with that. So let's start with this video and let's revise what we have learned up till now. So till our previous session, we had learned everything that this chapter has to offer. We had understood. Now I'm going to pick up with the parallel lines. So we had parallel lines, right? So let's say these were the two lines AB and this was CD, right? There was a transversal. Let's say this one was C. So you were doing what? If we had transversal, so I knew if I just focus on these two lines right here, I could see this angle and this angle will be equal. Those angles will also be equal. Why? Vertically opposite angles, right? And if I just focus on upwards, then this is 180. That means some of these two angles will be 180. Similarly, if I just look at these sides, that means if I consider T as a line, then some of these angles, let me just name them. So I'm going to do what? Let's just consider two parallel lines and one transversal. Okay. With the help of this, I will be wrapping up each and everything that we had learned up till our previous session. So let's just highlight the angles. Let's say this is angle 1, this is angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So this is how I'm going to name them. That is not a question here. You can name them accordingly that you want, but you just have to be sure about your basics. So you should be knowing which type of angles will be equal. Now I knew if these both lines, let's say this was the transversal T, this was L and this was M. If L was parallel to M, then we had understood that angle 2 will be same as angle 6. Angle 1 will be same as angle 5. Similarly, if I just move downwards, so angle 8 will be same as angle 4 and angle 7 will be same as angle 3. So this angle same as this one, this angle same as this one, and ultimately these two angles, this one and this one, both of them will be equal. So these are the four pairs of angles which will be equal. And how will they be equal? According to your corresponding angle theorem, right? Your exoim. So you had your corresponding angles exoim, right? So these are your pair of corresponding angles. Then we moved forward. If I just move forward, so these were the corresponding angles. If we had to find out your vertically opposite angles, so what were those? If if two lines were intersecting each other, so the situation where you did not have your adjacent angles but the angles which were opposite to one another, those angles will be equal. So that means angle 2 will be equal to angle 4, angle 3 will be equal to angle 1. Similarly, in bottom case, angle 5 was equal to angle 7 and angle 6 was equal to angle 8. All of these were your vertically opposite angles, right? Then we had alternate interiors, right? Alternate interior angles. Pardon me if I am just sounding weird because I'm having cold. So alternate interior angles, what were those? So those angles which were separated by your transversal and they were on the opposite side but inside of the parallel line. So you guys see here I get angle 5 which should be same as angle 3 and angle 4 that should be same as angle 6. So these were your alternate interior angles, right? Then we had what? Then we had, let's just call them alternate exteriors too, but those are not probably the case here, but we can just name them alternate exteriors also. So those will be the angles which are separated by your transversal, but they are lying on the outside. So if I had to talk about alternate exterior angles, so they will be what? Angle 1, that will be equal to angle 7. Angle 2, that will be equal to angle 8. Or you can just move around with another forms and you can just prove them. See, angle 2 will be same as angle 6. Its linear pair will be this angle 7, and I know linear pair of this angle 2 will be this angle 1. So you guys see, these two will be equal. Similarly, angle 2 will be same as angle 8. So you can just move around with various ways, and you can have alternate exterior angles also. So these were all the things that we had understood, and we had understood the converse of these also. So if a pair of alternate interior angles were equal, then the lines will be parallel. If the pair of corresponding angles were equal, then the lines will be parallel. So we had various of things. So all of these were the converse of one another. So one more thing, we had what? We had co-interior angles, right? So what were co-interior angles? Those angles were those which were having what? Which which were lying on the same side of transversal, but inside of the figure, or inside of the parallel lines. So that means they were supplementary to each other. That means angle 3 plus angle 6, that will be 180, and angle 4 plus angle 5, that will also be 180. So guys, see, if the lines are parallel, then some of their co-interior angles will be supplementary, or you can say if the sum of their co-interior angles is supplementary, then both of the lines will be parallel to one another. All these things were already discussed in our earlier session. And there we had one more thing. If two lines were parallel to the third one, then all of the three lines will be parallel to one another. That means if we had something like this, let's say this is line L, that is line M, and that is line N. And let's say there is a transversal T or not, that does not matter. You don't have to take that. But here we have this. If L is parallel to M and M is parallel to N, then this implies L should be parallel to N, or you can say L will be parallel to M, will be parallel to N. So all of these three will be parallel. There we had used our corresponding angles, right? So if L is parallel to M, then this angle is same as this one. If M is parallel to N, then this angle is same as that one. So ultimately, both of these two angles are two same. So that means L is parallel to N. So these were the things that have been discussed in our earlier session. So I hope you guys remember each and everything from the last session and the session before. Now let's jump to the questions. Right now we have just one more example with us. So this is our example 6, which was prior to your exercise 6.2. So in this example we have what? We have this. In figure 6.27. Yeah, I can explain corresponding angles again. See, let's consider this figure. See, let's just take this one. I have two parallel lines. Let's say AB and CD. These are the two parallel lines, and there is a transversal T. So first of all, you need to have your basics clear. See, the thing is, if AB is parallel to CD, now you have to look for corresponding angles. So you have to do what? Just look for those angles which are on the either side of transversals. So I can see this one can be one angle. This is on the either side. So let's just mark up each and every angle that I can see is on the right hand side of the transversals. I can see this, I can see this angle, and later I can see this one, and I can see this one too. Okay, these are the four angles which are on the right hand side of transversals. Okay, now we have to look for those angles which are on the left hand side of transversal. So you guys see, if I just look at this one, on left hand side I can see this one, right? Then if I move forward, I can see this. If I just move a bit further more, so I can see this one also, right? And lastly, I can see this, right? So these angles right here and these angles right here. Now you have to do what? You have just figured out the angles which are on the either side of transversals, but there is one more condition to be termed as the corresponding angle. So the pair of corresponding angles, you have to do what? You have to look for those angles which are lying, one should be inside the parallel lines and another should be outside. Now if I look here, see, if you look here, I can see this angle right here, this is outside of the parallel lines, right? And this one is on the inside. So according to corresponding axiom, it states that this angle will be same as this one. So what I mean is, the angle which is marked purple here, that should be same as the blue one. Or you can just name this one. Let's say this is point P, this is point Q. So you can see, let's name this EF also. So according to corresponding angles, your exam angle EPP, EPB, that means this one should be equal to angle PQD. That means this one. So one is outside the parallel lines, another one is inside. Similarly, if you look at this angle, this is inside and that is outside. So that means angle BPQ, BPQ, that should be same as P, sorry, not P, actually DQF. You have to be careful, DQF, you have to be careful for the namings. So remember, top one, one will be inside, one will be inside and one will be outside. Bottom one, one will be inside, another one will be outside. Similarly, here you can do it also. APE will be same as CQP and APQ will be same as CQF. So these are your corresponding angles. I hope I have cleared your doubts, right? So this is the doubt related to your corresponding angles. If you have any doubt, you can just ask me again. Should I start with the sum now? So I'm going to erase this one. If you have any doubt, you can ask me again. I will be happy to clear your doubts. Now you guys see I have this one in figure 6.27, which is this one. AB is parallel to CD. AB is parallel to CD and CD is parallel to EF. This line is parallel to that one. Now here you have to refer to that theorem where we had understood if pair of lines are parallel, that means AB was parallel to CD and CD was parallel to EF. We had understood that if these two were parallel and the second one was parallel to the third one, then first one will be parallel to third one. So AB will also be parallel to EF, or you can use your corresponding angles right here. So you guys see AB is parallel to CD, X will be parallel to, sorry, X will be equal to Y, right? Corresponding angles, one is on the inside, another one is on the outside, right? Then you guys know CD is parallel to EF. So this angle right here and this angle right here, if I consider this one as my transversal, let me just erase this. See, if I just look at this figure, you guys see AB is parallel to CD, right? So if lines are parallel, then their corresponding angles must be equal. So this angle right here should be equal to this one, right? And I know if the lines are parallel, then the sums of their co-interior angles is always 180. So you guys see the sum of this angle. Let's not use this one, this is quite darker. So if I use this, let's say this is the case, so sum of this angle right here, sum of this 55 and sum of this Y, this has to be what? This has to be 180 degrees, right? So what I'm gonna do, let's see. So I know that AB is parallel to CD and CD is parallel to EF. Now here you can write the theorem that if pair of lines are parallel, and then that means in triplets of line, if two given lines are parallel at a given time, then first and third will also be equal. So you can use that theorem and you can imply AB will be parallel to EF. Or you can do what? You know AB is parallel to CD. Then you can say what? Angle DB, or you can say, let's name this one as our X. So if I just focus on these two lines, see, AB is like this. This is your CD and this is AB. Now you guys see I have a kind of a transversal which is EB, right? It is passing through D intersecting at B, so it should be like this, right? This is point D, this is point B. And you guys see if I look at this one, if I extend this line, so this acts as a transversal to a pair of parallel lines, right? So that means this corresponding angle will be, a pair of corresponding angles will be same. So that means Y will be same as X. Why? Because corresponding angles, right? So X and Y are equal, and also I know CD is parallel to EF, then Y plus 55 has to be 180 degrees. This is sum of co-interior angles. So if sum of co-interior angles is 180, then Y will be what? 180 minus 55. Now you can easily solve this one. This will be 125 degrees, right? This is 125. So I got Y 125, and I know Y is same as your X. So X itself will be what? 125 degrees. Now there are multiple ways to have this sum. Now you guys already you can do with this method also. There is one more way with this. So remember your X is 125 and your Y is also 125. Now we can move with another method also. Now if you guys understand AB is parallel to EF, then you guys will already be understanding that the sum of these two angles, right? Sum of these two angles has to be what? Has to be 180, because the lines are parallel, then their co-interior angles have to be 180. That's the one way to find out Z. There is another way. I will be explaining both methods. So I know these two have to be 180. So that means angle CAB plus angle Z plus 55 degrees. That has to be 180, right? Sum of their co-interior angles is always 180. So I know CAB is 90. This is 90. This is 55. And that one is Z degrees, right? That is equal to 180. I hope you don't have any doubt in this. Or you can do what? You guys know this is 90 and both of them are 180. So these two have to be 90, right? See, if angle A is 90 and I know angle A plus angle E has to be 180, then angle E itself will be what? It will be 180 minus 90. That means 90 degrees. Or you can do this one. Z plus 55, that will be equal to 90 degrees. Z will be what? You can just solve this one. This will be what? 35. So Z will be 35. That's one way. Or you can just find out Z here. That will also be 135. Sorry, actually 35, right? This will be 145. 180 minus 145. That will be Z. So Z will be what? It will be 35 degrees. That's the one way to solve this one. There is one more way. See, if you look at these two lines right here, these two are parallel. This is 90. Then this can also be 90. Again, corresponding angles, right? So if this is 90, I know I can find out the value of this angle. This was already calculated. It was 125 degrees. So if I take its linear pair, and actually I don't have to take the linear pair also, I know these two lines are parallel themselves and this is the transversal. So if this is 55, this can also be 55. Vertical, sorry, alternate interior angles, right? If this angle right here is 55, then this will be 55. If this is 90, then corresponding angles, this is also 90. 90 plus 55, you can easily calculate using your angle sum property of triangles. So you guys know sum of all angles is what? It is 180 degrees in the case of triangles. That has already been taught to you in your earlier classes too. So don't worry, I will be proving this concept later on. We have this concept just after this exercise. So you will be having this one. So you can use that method also. You can easily calculate Z there. Now you have already calculated Z. You know this is 90. Then you can find out this angle. Then linear pair, you can easily find out this one. Then these two are equal themselves. So there are various ways to attempt this question. The easiest is the simple one. You just have to look for these two first. You can calculate Y, take that value, find out X. Now you guys know, take that linear pair, put it here. 90 plus the linear pair value plus the Z. Since ABE is a triangle, so you will be getting what? You will be getting an angle of 180 degrees and you can easily calculate Z. Or you guys know 90 plus this has to be 90. You can get Z there as well. So there are various ways that you can move around with some questions. Actually, in the case of lines and angles, there is no one particular way. You can have as many ways as you want in order to solve your sum. So you can use any method provided that method is correct. So I'm going to move forward and see. This is our exercise 6.2. This is quite easy. You have to show that AB is parallel to CD. Now I know I have been, firstly I have to find out X and Y, then I have to show that AB is parallel to CD. Now you guys remember, a pair of lines can be parallel if its alternate interior angles are equal or its corresponding angles are equal. So these are the things that we already know, and we can know this one also if its alternate exterior angles are equal to. That can also happen here. But for the sake of argument, I know I have been given that this is a transversal. Let's say this is the transversal T. AB and CD are parallel. Okay. Now you guys know this is 50 degrees. Then if I take linear pair, this will be what? 180 minus 50. X plus 50. That has to be 180, right? Because linear pair. Then X will be what? It will be 130 degrees. Now you guys know this is 130 and you cannot use alternate interior angles to find out Y, since the lines are not parallel. Remember, AB has to be proven parallel to CD. So you cannot use alternate interiors here. What you can use here is, if you just focus on this one, this line right here. You guys see in this case, in this line, I can see the transversal is intersecting CD at this point, and I know the vertically opposite angles have to be equal. So that means Y will be same as 130 degrees. So I know X is 130 degrees, Y is 130 degrees. So a pair of alternate interior angles are equal, then lines are parallel, right? So if this is the case, then AB will be parallel to CD. So you have already proved this one. So I hope you guys understand this. See, the reason is you can do the basic part first, so you can do this one. So you guys see, I knew this. If I just focus on this one, I knew this 50 and this x together will be amounting to 180 degrees, right? Because it is a straight line, then AB will be acting as the transversal. So you guys see, oh, you can just do with this method also. If you are getting confusion why we are taking transversal as a straight line, not AB, that does not matter. You can take linear pair there also. So you guys see, this is 50 linear pair. This will be what? This will be 130, and I know there is an x. So this 130 will be same as this 130, this x. That means vertically opposite angles. The choice is yours. You can take any value as you want. Even you don't, if they hadn't asked you to find out the value of x, then you could have just done it with this method also. See, this is 130, vertically opposite, this is 130. Y is same as this angle, pair of corresponding angles are equal. Again, lines are parallel. So you can move forward with any method to prove such scenarios. Just you have to get your basics clear. Remember, lines can be parallel if corresponding angles are equal. Sum of their co-interior angles is 180 and their alternate interior angles are equal. Even alternate exterior angles are equal to. That can also happen. So there are various ways to move around this question, but your method has to be correct. So one method I've already showed you and another I have explained it to you. So choice is yours. You can use any method in order to solve these sums. So I'm going to move forward since the lecture might be getting quite lengthy. I have to complete this one now. So you guys see in this figure, we have what? AB is parallel to CD and CD is parallel to EF. Quite easy question. You guys can easily solve this one. We have been given the ratio between Y and Z. These two angles are already in ratio. So we have to find the value of x. I think we have already done this one, or might be. So see, I know AB is parallel to CD and CD is parallel to EF. Therefore, this implies if AB is parallel to CD and CD is parallel to EF, then AB is parallel to EF. So if this is the case, if AB is parallel to EF and this is the transversal right here, so you guys see x will be same as Z, alternate interior angles. Do you have any doubt in this? I hope you guys are not having any doubt. Now you guys see, I know if AB is parallel to EF, then x, this angle right here, let me just highlight this one. So this angle and this angle, both of the angles are opening their faces in the opposite direction. If we just get rid of this CD, you guys can easily see, right? So this x will be same as Z, so both of them are equal. Now I just come back to the point right here. I know CD is parallel to EF too. Now this line right here is parallel to EF. If this angle is on the inside, then this one has to be outside and it is on the same side of transversals. So if I just name the points right here, let's say if I name this one as our x, this one as our y, and this one as our, sorry, we cannot take them because those are already in the angle naming. So I'm going to call this one, let's say PQR. That will be quite easy. This is P, this is Q, and that one is R. Now guys see, if I name this one angle PQP, that means this angle will be same as angle QRFY, corresponding angles. So if this is x, then it has to be x, and CD is a line, and CD is a line. Therefore, this Z was x, so I'm calling it as x. That does not matter. You can take Z also. So I'm going to call this one as our x or Z. Choice is yours. Let's just call this one as a Z, since we have been given the ratio between y and z, but that does not matter. So z plus y, that has to be 180 because of linear pair. Easy, right? So if they are 180, I know the ratio between y and z is what? Keep in mind, y is first, so this is the value of y, z is this, and this is that. So if we take ratio x, so y should be 3x and z should be 7x plus, that should be 180. So x is what? 180 over 7 plus 3, 10 divided by 10. So it will be what? 18 degrees. So we do have the value of our ratio now. We just have to find out the angles. So y will be what? 3 into 18, that has to be 34 degrees. Z is 7, 7 into 18, that has to be what? 126 degrees. And I know x is same as z, so x itself is what? It is 126 degrees. So this is the method that we can use in order to calculate the values. Although you can use any method that you want, but your answer will be still the same. But don't worry, if you are taking this one as your x, So if you are given ratio between y and z, which is 3:7, don't worry, it's the same ratio, y is to x, which is 3:7, since z is same as x. So your ratio will to be same. I hope you guys understand this and you don't have any doubt in this, right? So quite easy question. Let's move forward. So let's start with this one. In figure 6.30, which is this one, AB is parallel to CD. AB is parallel to CD. EF is perpendicular to CD. EF is perpendicular to CD. You can see the right angle right here. And GED is 126. GED. That means this complete angle, this is 126 degrees. AGE. AGE. That means this angle we have to find out. GEF. GEF. That means this angle we have to find out. FGE. FGE. That means this angle we have to find out. Now, this is a very important question. This is very important, but this is very easy too at the same time. Now, you guys know AB is parallel to CD. That has been clearly given to you. So, you guys see, if AB is parallel to CD, then remember this. If I, for a sake of, let's say for a moment, if I do what? Let's just keep in mind, bear with me, just ignore this right here. Ignore this EF for a second. So your figure should be looking like this. This acting as a transversal and this is the parallel line, right? Now you guys know, if you just ignore this for a second, so you have EG which is acting as a transversal. Now you guys see AB is parallel to CD, then pair of alternate interior angles have to be equal. And you guys already know GED is what? It is 126 degrees. If this is 126, then this has to be what? This has to be 126 too. Now you will be asking me why. Criteria of triangles, that should be, I guess you're talking about congruency, right? Yashasvi, the congruency will be discussed while we are on chapter 7. That is going to be held on Tuesday, so do join me for that. But if you're having any doubt regarding triangles, so criteria of triangles is quite straightforward. There are various ways, but you have to always assume this one. See, for a triangle, if you consider all its three sides, sum of two sides always has to be greater than the third one. That is the main criteria for any triangle. I hope this is what you are asking me. But we will be having various criteria for triangles while we are on that chapter. So till then, just remember this is not the part of that one. We are just talking about lines and angles. Triangles is a total different topic, although this we will be having this one there also, but that is different from this one. So we will be discussing that portion there. For now, this is the case. So if this is 126, then this has to be 126. Now I know out of this 126, this is 90. Then remaining this one will be what? Whatever the value is, I guess this will be 36. So this is the value of angle GEF. So if I just do it here, I know AB is parallel to CD. So this implies angle AGE will be same as angle GED. AGE, this one, GED, this one, equals to 126 degrees alternate interior angles. Now I also know angle GED, that is same as angle GEF, that means this, plus angle FED, which is this one. Let me just write it neatly. So FED, which is this one, this is 90, right? So you guys know this is 126 degrees. GEF I have to find out. So GEF plus 90. So angle GEF will be what? It will be 126 minus 90. So that should be 36 degrees. Easy. Now we have calculated this 36. I know this is a straight line. We can easily calculate this one. We have to find out FG, right? So take the take the linear pair here. This is 126. So 180 minus 126. So you will be getting an angle which is 54 degrees. So angle FGE, that will be 180 minus 126 degrees, not 1260. Let me just write it neatly. So this is 126 degrees, right? This is linear pair. So it should be 54 degrees. So these are the all angles that you have to find out. Even you can calculate this one also. This is quite straightforward. If this is 90, this is also 90, or you can take this one also. So there are various ways to get around this question. You can just take the linear pair also. You can take the sum of triangles also. So we can have anything that we want. We can attempt with that method. Now in this one, this is quite straightforward. They have already given you the hint. But remember, you don't have to look at this hint, because in your examination, you won't be provided any hint. You have to just figure out that one on your own. So I'm going to erase this one. We are not going to take help of the hint right here. We are going to attempt each and every question with the general knowledge and the conceptual portion. So you guys see in figure 6.31, PQ is parallel to ST. This PQ is parallel to this ST. Angle PQR, which is this one, is 110 degrees, and RST, which is this one, it is 130 degrees. We have to find out angle QRS. We have to find this angle. Now guys, see, in these kind of figures, always do what? Just complete the figures by extending the lines. So I'm going to extend this one. So let me just draw this one. This is our PQ, QR, that will be the case, right? So our figure is looking like this one, PQ, ST, and that one is R. We did what? We extended our PQ, let's say to a point X. So I know if PQ is parallel to ST, then PX will also be parallel to ST, because PX is the part of PQ. So if this portion is parallel, then this entire will also be parallel. I know this is 130. I know when the lines are parallel, sum of their co-interior angles is what? It is always 180. So if I name this point, let's say this is the point B. So I know angle SBX plus angle BST. That will be what? That will be 180 degrees, right? So I know angle SBX, that will be what? 180 minus 130, that will be 50 degrees. So this is 50. I know this is a straight line, and this is also a straight line, so vertically opposite angles. So angle QBR will be same as angle SBX, which should be 50 degrees as well. So if this is 50, this is also 50, right? And you guys know we have to calculate this angle, remember. And this is a straight line, this is 110. So if I take linear pair, this will be what? This will be 70, right? 180 minus 100, and this is 70. Now in this you have a triangle right here, QBR. So you guys know 70 plus 50 plus angle R, that will be 180. So angle R itself is what? 180 minus 120, that will be degrees. So this is the answer. You have your angle R, which is degrees. There are various ways. Even if you can extend that line, you can extend this one also. You can extend ST, then you can follow up with the question. You can have any method that you want. This is the basic approach. We are going to approach with this method. I hope you guys understand this and you don't have any doubt in this. Now let's move forward and see. We have this fifth question with us. We have this one. AB is parallel to CD. See, you have been given that AB is parallel to CD. Let me just use the highlighter here. So this line right here, AB is parallel to CD. APQ, that means this angle is 50, and PRD, that means this is 127. We have to find the value of X and Y. So we have to do this one. So I'm going to do what? Let's erase this for a second and see what we can do here. If I just look at this portion, AB is parallel to CD, and this line right here, this is what? This is acting as a transversal. Now you guys see, if I ignore this portion right here, if we don't take this PR, you guys see this is 50, so this has to be 50, because both of them are lying. They are separated by your transversal, which is PQ, and are lying on the opposite sides of the transversal. So you guys see they have to be equal since they are inside. So I know if I write this one, angle APQ will be same as angle PQR, alternate interior angles, right? So APQ and PQR, X will be what? X will be 50 degrees. Quite easy. Now don't get confused here. If you just look at this one now, I'm going to erase this one. We can simply use that method also to calculate the value of Y2. So see, we are not going to approach this method with the angle sum property of triangle, although we can do with that method also. I will be explaining that. See, if I just focus on this again, AB is parallel to CD, but this time I'm going to consider this one as my transversal. So you guys see this angle is 127. So this entire, don't get confused here, not only X, this will not be the case. You cannot consider just Y here. You cannot get the value of Y directly, because you guys see this complete angle will be same as this complete angle, since there is no line segment PQ, and this angle is not being separated. So you guys see APR, this entire angle APR will be same as angle PRD, which will be 127 degrees, that is alternate interior angles too. But here you guys know APR will be what? Angle APR will be 127 degrees, but that is made up of a 50 degrees and a y, so that should be equal to 127 degrees. So y will be what? 127 degrees minus 50 degrees, so you guys see this will be 77 degrees, right? So quite easy. You can approach with this method if you want, or you can approach with different method too, where you can do what? That will be quite easier for you. Just do what? Take the linear pair here. This will be what? 127, 180 minus 127, that should be a 3, and this will be a 5, so this is 53, right? Now you guys know this is 53, this 50 and this 50. 50 plus 53, 103, and 180 minus 103, that will be sorry, that will be 77. So you guys see, you can approach with that method also, but in that case you have to use the angle sum property of triangles, which has not been discussed yet, but we are about to. So let's move forward. So now we are going to talk about the angle sum property of triangles. You guys have been using this identity since your class 6 and 7 too. You have been using this one in your class 5 also. So this identity states that if you add up all the angles of the triangle, then you will be getting a sum which should be 180. And you guys remember the sum of interior angles, n minus 2 into 180, that was what? Sum of all interior angles, right? So this was also your thing that you had studied in your class 8th in chapter quadrilaters, right? So you had this method also if you had been given any quadrilater starting from your triangle up till your C. If you want to find out this angles, sum of all interior angles of triangle, you guys see n is the number of sides. So in triangles we have 3 sides, so 3 minus 2 into 180. So you guys see 1 into 180, so henceforth you have sum of all 3 angles of a triangle has to be 180 if that is a triangle. So that is another property of a triangle on the basis of angles. Now we have to prove that angle 1 plus angle 2 plus angle 3. 1, 2 and 3. All of these 3 should be 180. Now this is quite straightforward sum. We are going to take help from the previous example. So I'm going to do what? Let's extend these lines. Now you guys see, I know sum of these two angles was same as this one, alternate interiors. So angle 1 plus angle 4, that was same as this angle y, z, and let's name this one as our b. So y, z, b. Okay. Now you guys know how can we calculate this angle 3? I know angle 3 plus angle y x b, that will be what? That will be 182 linear pair. And I know this angle 5, this angle right here, sorry, not that one, let's just erase this angle right here, this angle 4. Now you guys see, this 4 will be same as this 2, this can be written as 4 2, right? Angle 4 will be same as angle 2. So in this case, can I write it like this? Angle 1 plus angle 2, that is equal to angle yxb. I hope you guys are getting this. See, let me just do it again. See, I know this line right here is parallel to this one. I'm going to do what? Extend the lines on the both sides. So you guys see, let's name this one as our AB and let's name this as CD. Okay, let's ignore this point and let's say this is CD. Now you guys see, this angle 4 will be same as this angle 2. Lines are parallel, this is the transversal, so alternate interior angle. So first of all, we deduce this, that angle 2 is same as angle 4. Okay, this is angle 2 which is same as our angle 4. Okay, let me just write it again. So angle 2 same as angle 4, and I know if I just look at this one, if I look at this, I know there are variety of ways in which we can prove this one that can happen here. So you guys see, if AB is parallel to CD2 and this time YZ is a transversal, we can say angle 5 will be same as angle 3. Why? Alternate interior angles. And I know this CD is a line, sum of all these 3 have to be 180. So angle 1 plus angle 4 plus angle 5 has to be what? Has to be 180. I know 4 is same as 2. So angle 1 plus angle 2. I know 3 is same as 5. So angle 1 plus angle 2 plus angle 3, that is 180. And you guys say sum of all 3 angles of a triangle is 180. Understood? Now here I want to explain one more thing, which is our another theorem. So we are going to explain it there. I'm not going to do it now. So this is the proof. You can have it either way. Either you can use this one or you can use the previous example. Then you can even prove that one also. Now let's move forward and see what do we have now. So it is the theorem 6. This is very important. Most of the time we are going to use this one. This is commonly termed as your exterior angle property. You guys have understood this one in your class 7, I guess, in your chapter triangles. There you had that exterior angle property where you had this, that the exterior angle is always equal to the sum of two interior angles. That means angle 4 should be equal to angle 3 plus angle 1. This is the scenario wherever we are extending the line, then the angles which are opposite to that one, that means the previous two angles, in this case these two angles, sum of these two angles will be same as this one. Now this is quite easy, you can prove this one on your own, or you can have me to do that. See, I know this is a straight line, I'm going to use the basic one. So angle 2 plus angle 4 has to be 180. Why? Yeah. And I know this is a triangle, so I can do this one also. Angle 1 plus angle 2 plus angle 3, that should be 180, because we have just proved this one, that sum of all interior angles of a triangle is 180. Now you guys see, angle 1 plus angle 2 plus angle 3. Here I calculate the value of angle 2. Let me just erase this one. I'm going to do what? I'm going to calculate the value of angle 2. That will be what? 180 minus, if I take the bracket here, angle 1 plus angle 3, right? These two will be subtracted from 180 and you will be getting angle 2. Now replace that value here. So 180 minus angle 1 plus angle 2, angle 3, not 2, plus angle 4, that is equal to 180. Equalities and same things cancel out. So this is negative, on the other side that will be positive. Angle 4 is equal to angle 1 plus angle, and this is what we have to prove in this case. So I hope you guys understand this. So that is the meaning of the statement, that exterior angle is always equal to the sum of two opposite interior angles, and this property is commonly termed as your exterior angle property. So I hope you guys don't have any doubt in this, because we are going to start our exercise 6.3 now. So let's just start with that one if you don't have anything. Yeah, this is one example. This is most important example from your NCERT. This might be your example, I'm not sure, might be 13 or 12 or whatever that is, but this is the last example prior to your exercise 6.3. This is very important. See, if the internal angle bisectors of angle ABC and BCA of a triangle ABC intersect each other at point O. First of all, what it states, let's take a help of the figure. We have a triangle, let's say this is the triangle ABC. It states that the internal angle bisector is what? Bisector is that line that divides any quantity into two equal parts. But we are talking about angle bisector, so obviously it will be dividing your angles into two equal parts. Now you guys see, we have two bisectors of angles ABC. That means there is a bisector of this angle and there is a bisector of this angle too. That means ACB, or you can say BCA. So let's just name this one. They are intersecting at O. So obviously I'm going to name them OB and OC. Right? So let's just erase this and have our second bisector. Will be the case. This is OB and this is OC. Okay. You have to prove that angle BOC, that means this angle right here, that should be 90 degrees plus half of angle A. Remember, this property will be used in your MCQ type questions while you're attempting questions in which you have to just directly find out the answers. So this is one of the proofs here. Now you guys see, if I just focus on a triangle, in triangle ABC, if I just focus on this triangle, I know angle A plus angle ABC plus angle ACB, that should be 180, right? This angle, this complete angle and this complete angle, sum of all three angles is what? It is 180 degrees. I hope you guys get the point here, right? Now you guys know OB and OC are the bisectors. They are what? They are the bisectors of angles ABC and angle ACB respectively, right? So you guys know, if the angles are being bisected, that means angle ABO, that means this will be same as angle OBC, that means this one, right? Both of these two will be equal. Similarly, angle ACO, that means this one will be same as angle OCA, that means this one. Now in place of ABC, angle ABC, can I write it like this? Angle ABO plus angle OBC, ABC, ABO, this one, plus OBC, this one, amounts to angle ABC. I know both of them are equal. So angle ABC is same as twice of angle OBC. So if I just take this angle, multiply it with 2, I will be getting angle ABC. Or you can say angle OBC. That is what? That is 1 by 2 angle ABC. Right? I hope you don't have any doubt in this part. Similarly, if you move on to the other side, you will be having this one. Angle OCB will be half of angle ACB. Exactly same way, you can easily prove that one also. So now you guys get the idea that this angle is half of total, this angle is half of total. Now we are going to come back to the statement. So I'm going to do what? Let's erase this. So I'm going to have those proofs written here. I'm not going to erase those. So I know ABC is same as twice of OBC, or you can say angle OBC is half of ABC. So in place of ABC, can I write it like this? Angle A plus twice of angle OBC plus in place of ACB. Can I write it like this? Twice of angle OCB. That should be 180. Right? So if I erase this one, if I just erase this one now, so if I try to find out the values of these two, twice of angle OBC plus twice of angle OCB, that will be what? 180 minus angle A. If I just try to half that, if I try to find out value of OBC plus OCB, considering 2 common, that will be same as 180 minus angle A whole divided by 2. I hope you don't have any doubt in this part, you don't have any doubt in the statement. See, 2 is being multiplied here, 2 is being multiplied here. We can take out that 2 common and it is in multiplication. On the other side, it will be in division. So you guys see, if I separate this one, that will be same as this one. 180 divided by 2 minus angle A by 2. So ultimately this will be what? 90 minus angle A divided by 2, which is the value of OBC plus OCB. So the values of these two angles is 90 minus angle A by 2. Now this is our proof right here. We are almost done with the sum. So we are going to move towards a shorter triangle because we have to find out the value of BOC, right? So BOC is the part of the triangle which is inside the triangle. So I'm going to erase this one. So let's move with that one. In triangle BOC, angle BOC, that means this, plus angle OBC, that means this, plus angle OCB, that means this one, all should be equal to 180, right? Angle sum property. I know these two are 90 minus angle A by 2, right? Plus angle BOC, that is equal to 180. Now angle BOC will be what? 180 minus 90 and minus plus angle A by 2. 180 minus 90, 90 plus angle A by 2. So angle BOC is equal to 90 minus angle A by 2. So this is the proof right here. I hope you guys understand this proof. You guys have got the point. Remember this one, we are going to use directly this value when we are talking about a triangle inside a triangle made up of the bisectors of 2 angles. So remember, this is an important proof right here. You have to use this one. This will be used in your later sums. So I guess we should wrap it up here. We have exercise right now, right? So we are going to have this exercise 6.3 when we are going to attempt a doubt session. So I will be having this exercise along with some important questions to be discussed just purely in your doubt sessions. So that's just that session will be on Monday. I will be joining you on Monday. So if you have any doubts, you can just ask me on Monday, but you can do all this also. You can just log on to this website, download our application. You can have your doubts there, get yourself registered, have one-on-one interactions. You can have tons of sums to practice on. You will be having various test series related to each and every chapter. We have various things there. Just don't wait for the chance because we are running a brilliant offer there. You are getting each and every subject, your maths, English, your SS, your one other subject, what was that? Science. So math, science, English and SS. All these 4 subjects will be included in that package. That is quite cheap. You can just log on to the website, download our application. You can get the prices also. You will be having certain discounts in coming weeks. So attend for that, be attentive. Until then, practice as much as you can. I will be seeing you on Monday. So join me on Monday as well. I'll be having you in your doubt sessions. I'll see you on Monday. Bye for now.